Hi, I wanted to go over a couple questions for you. So the first question is number 11, where f is 1 divided by square root of x and g of x is x squared minus 49. It says state the domains of the following function using interval notation. So first of all, f of x is defined on all real numbers other than 0, right? So for f of x, x cannot be equal to 0. Where g of x is defined over all real numbers, so no requirement there. However, when we're dividing f of x by g of x, we also have to make sure that g of x is not equal to 0. And when would g of x be equal to 0? Well, we can set it equal to 0, and then we can solve, and that would mean that x either is plus or minus 7. So if we are giving this in interval notation, means we have to exclude 0, we have to exclude 7, and we have to exclude negative 7. So our domain goes from negative infinity to negative 7, right? If we're looking at a number line, we have our first excluded value at negative 7, we have our second excluded value at 0, and then our third excluded value at 7. So we have this together. So we're going to do the union from negative 7 to 0, or again, the union symbol from 0 to 7. And then lastly, we can go from 7 to infinity. So that takes out negative 7 over here. This takes out 0, and this takes out 7. Alternatively, if we first apply g of x, then apply f of x, g of x has no excluded values, but again, we cannot divide by 0, and therefore f of x has an excluded value of 0. So if g of x cannot be equal to 0, which again gives us the value of x squared minus 49 is equal to 0, when x is equal to plus or minus 7. So this time we don't have an issue with plugging in 0 as we did before, because right now, the only way we would get a 0 down here would be if g of x is equal to 0. So therefore the only excluded values are plus or minus 7. So we end up with negative infinity to negative 7, and the union of that with negative 7 to positive 7. And then the last part is from 7 to infinity. All right, for this last example over here, we first apply f of x, then g of x. So in order to plug something into g of x is a polynomial function, has no restrictions. However, f of x cannot have a 0 down here, so therefore x cannot be equal to 0, which means we are going to exclude 0 from our domain. And that is the answer for the first one. So for our first example, we had to look at what would make g of x equal to 0, since we cannot divide by 0. But since we had f of x in the numerator, we also, when we had 1 divided by the square root of x, we also couldn't plug in 0. So we had 3 excluded value. For our second example, we have f of g of x. And so g of x could not be equal to 0, and that gave us those 2 excluded values. And when we switched that around and did g of f of x, we just looked at the excluded value for f of x because g of x has no excluded values. That is question number 11. The second question I promised to go over was question number 16. This is a composition of functions. We are given 3 different functions over here. I'm just going to go over, 1 or 2 examples over here, but I also like to rewrite this as f of g of x. So instead of the composition symbol, I like to do parentheses, because what that means is we are first going to plug in our inside function. So instead of g of x, we're just going to write down what g of x is, which is x minus 3. Then I like to use the skeleton function for f of x, where f of x is a function squared, or an x value squared plus 7. But instead of writing an x squared plus 7, I'm going to fill in this value. So it's x minus 3 squared plus 7. We can now expand that and rewrite it. So that's the same as x squared minus 6x plus 9 plus 7, which is equal to x squared minus 6x plus 16. So that's question number 1. Let's maybe look at the last question as well. So the same idea, we're going to first rewrite this with parentheses. Then we're replacing the inside function with g of x. And then we're using that skeleton for h, which is the square root of x, which is square root of x minus 3. You would do the same thing with g of f of x. Just rewrite it with parentheses, replace the inside with f of x, which is x squared plus 7, and then apply g of x by using that skeleton, putting parentheses instead of the x, and then filling in the value of f of x. All right, hopefully that helps.